Hello and welcome to another session in the Vector Virtual Week. My name is Ingo Nickles. I am a field application engineer working for Vector for more than 8 years now. I'm responsible for our product, VectorCAST. I'm doing trainings and support. And with VectorCAST, we help people in embedded unit testing, or we help with measuring code coverage on the target or on the host. And in this session, I want to say something about lessons learned from testing in the highest levels of criticality. We started with avionic in the 1990s, and many of the requirements that came from avionic were also introduced in other industries, like automotive, for example. And I want to discuss things that are similar in the industries, but also things that are specific to avionic, things that may be or are already introduced in other industries, and how they can be realized with, for example, a tool like VectorCAST. The title of my presentation is Automated Software Tests for the Highest Criticality Levels in Practice. And as mentioned, we started in the avionic industry, so let's first have a look at history. The history of avionic started even in the early 1980s with the 0178. And already in the 0178B, 1992, a dynamic software test process was required. Dynamic unit testing, measuring code coverage, things that came much later in other industries. So we can see that avionic is, let's say, some 20 years ahead of other industries. So it may be of interest to look at the 0178C and the specific requirements coming from that standard, because as we see that software develops in other industries, becomes more complex, takes more safety critical functionality, more responsibility taken by software, we will expect a higher level of requirements regarding software quality and software test. So when we look at the 0178, there are many things that are similar to other industries, like, for example, classifying the software into different levels of criticality, having different levels of testing, like low level, high level, or system level testing, measuring code coverage. Those are all things that are comparable to other industries. But one thing that is, well, more or less not necessarily unique, but specific to the 0178 is test case execution must be done on target. It is not enough to say we run our unit tests on a host and we are happy with the results because we do the system level testing on the real target. In the 0178, you have to do your unit tests also on the target, and this is a way of making sure that the software really works as expected on the chip where the software, where your final product runs in the end. It also kind of qualifies the compiler that is used because you really run your functional test cases on the code using your compiler, using your chip, and then you see that in the end, the software works as expected on the final product. Another thing that is specific to avionic is that test cases have to be linked to requirements, to functional specifications of the expected results. It is not enough to just have a test case for the purpose of measuring code coverage. Specific to the 0178 is the data coupling, control coupling analysis, whereas I've heard that someone said that ISO 26262 would have similar requirements, for example. What this data coupling, control coupling is about will be shown, or I will show it on the next slide. And then there is something like tool qualification, which is very important for the 0178 or for testing software in the avionic industry. And it's a way of getting trust in the results of your testing activities. It's not enough in avionic to have a certificate for your test tool. It's not enough to have a piece of paper where it says your software, your test software works and provides proper results, you really need to validate the results of your test tool in your specific test environment. And this is something where you need to run prepared source code with prepared test cases in your test environment and then validate that you get the expected results that you would expect with this configuration. So this is important in the 0178. We have also seen that this kind of tool qualification is necessary. For example, if you want to certify an avionic industry, specific products also need this kind of tool qualification. There is a supplement to the 0178, one of 4 supplements, and the only supplement that is not specific to avionic is the 0330, which deals with tool qualification, and this is domain independent. That means it could also be used by other industries. Now, let's not forget that all of these requirements are here to help us in producing higher software quality or software of higher quality or of the highest possible quality. It's not here to make you angry or to make you additional work. It should help in software quality assurance, and this is something that should be of interest for everyone, for your customers, for you yourself, and for us as tool vendors. So some words about data coupling and control coupling, as we think that they are required from the 0178. The idea is that you understand your system, that you know how your system works, and that you prove that you understand your system, and you prove that your system works as designed, as documented. You should divide your system into subsystems. And each subsystem should be independent from the other subsystem. That means encapsulate the data processing, encapsulate the control processing, no data access between different subsystems as far as possible. But this is very often not possible, so then you need to document and to test that the data access between subsystem and the control access between subsystems is understood and only happens as documented, and that you validated, that you verified with dynamic test cases that these and only these accesses exist. So if we look at our example here with 4 subsystems, then you look at couples of subsystem, each subsystem analyzed with each other subsystem. So in our case, we have 6 subsystem couples. And for each of these subsystem couples, you have to look at data access. That means, for example, if subsystem 1 accesses a global variable of subsystem 2, then that would be a data couple. Or a control couple if, for example, subsystem 3 calls a function in subsystem 4, then that would be a control couple between subsystem 3 and subsystem 4. Now, let's look at the solutions that we provide from Vector. And my focus is, as I said, on the tool called VectorCAST, which helps in low-level testing, that is dynamic unit test. We also help in high-level testing, and that means software integration level testing. We can run unit tests or integration level tests on host, on simulator, on emulator, or on target using VectorCAST, and we can also measure code coverage. And we can measure code coverage from all levels of testing, from low level, high level, or system level testing. VectorCAST is certified to be used in more or less all industries, and it's also qualifiable to be used in avionic in the 0178, and we have qualified VectorCAST in hundreds of projects since the 1990s in the specific test environment configuration of our customers. So if we look at the time beam, the time frame, then VectorCAST, the first version of VectorCAST came pretty much with the 0178B at the same time. And this is the history that we have in this embedded testing industry, so almost 30 years. I said that we can help with an embedded unit test, and this is how it works. We analyze the source code, we analyze the C code, the C++ code, or ADA packages. We parse the code, then we automatically build a test harness, a unit test executable that exists, that has a test driver. So we automatically build the test driver, we automatically build stubs. And then we use your compiler and your linker to build a binary, to build an executable, to build an elf file or a hex file to be dynamically executed on the chip. We get the results back, and then we produce the reports on the host. Test case data is separated from the unit test executable, which is very helpful if you want to run in different configurations, if you want to verify, to test the same software on different chips using different compilers or in different configurations like different compile defines, then we can reuse the same test case data in different configurations. And this is shown on this slide. This is a screenshot of a VectorCAST project, a project view, a test view, where we have 3 different compiler nodes. GCC compiler, Green Hills compiler as an example, on an RH850 board with a minimum configuration. That means hash defines are set where some code is eliminated. And then we also have a maximum configuration. So an example of 3 different compiler configurations. We have 2 unit test environments, one on database, one on manager. And if you as a developer, if you as a test engineer want to create test cases, want to dynamically execute unit tests, then you can use VectorCAST. We will pre-process the code using the GCC compiler in this variant, parse the code, and then create drivers and stubs automatically, and you get your unit test Windows executable. You can create your test cases that give you, in the best case, 100% code coverage, and then you can run the test cases, and they will be executed on your local PC, on your laptop, using Windows. Now, this is not enough, as I said. In avionic industry, you need to make sure that the code also works using the real compiler on the real chip, and in an ideal world, in all possible variants. So you can use VectorCAST to create additional variants, and then we will use the different configuration on the same source code, pre-process the code this time using the embedded compiler, build a test driver and stubs, and compile and link using the embedded compiler. That means in this case, you will not get a Windows executable. You will get an ELF file or a hex file for your chip. But we can reuse the test case data that was created using GCC and then run and verify that the code still works on the real chip, on the embedded hardware. And this is what you need in the end to have the highest level of confidence in the results of your testing. Now, when we test in multiple variants, then the number of test cases increase dramatically. So time becomes an issue. And that's why we invented something called change-based testing. With a change-based test execution, we can analyze, if you do source code changes, like in this case, one file changed, then we can analyze which unit test environment is affected by the source code change. And even more, we can analyze which test case is affected by the source code change. And then we can incrementally rebuild only those test environments affected and only rerun those test cases affected by the source code change, which can really reduce the time it takes to run test cases. And this is important if you think about an integration of your development process into DevOps. If you want to optimize your workflow when developing and testing your software, then you should test as early as possible, because the earlier to test you test, the less it will cost to fix a bug. And that's why, for example, this is an example workflow of how you could implement your source code management commit process. There could be some quality gates that are automatically verified before allowing the SCM commit. And then when it comes to the execution of test cases, your software developer or your test engineer will probably not want to wait hours or days for results of your testing. So with the change-based testing approach, we can reduce the time it takes to run test cases because we only run relevant test cases. So you can implement a SCM commit process like this, where you also execute relevant or affected test cases by source code changes. Now let's look at VectorCAST in practice. Here we see a VectorCAST test project, as I also showed a screenshot in the slides. There are 3 different compiler nodes. That means we execute our unit test cases in 3 different variants. I also added here a system test for the data coupling control coupling verification. And in system level testing, you usually have all of your files in your test project. Then with the coupling analyze, it is important to define what are your subsystems, what are your components in your system. And with VectorCAST, we allow you to define what files are part of what component. So in our case, we have 3 different subsystems or 3 different components called main, SS1, and SS2. And these are the files that are part of the different components. Then the workflow with VectorCAST looks like this. We can do an analyze on the subcomponents. With that analyze, we see which global variables are accessed from one component in another. And we also see what functions are called from one component in another. Then when you apply, that adds instrumentation points to the source code, so that when the source code is executed in your system test, and this can be canoe test cases, it can be any other kinds of test cases that you run, then we see which couples were executed or not executed, and we also see what was the order of execution. For this purpose, it's helpful to import, after the test case execution, to import the results by test case. So here we have 3 different test cases with the names correct, full, and incorrect. After the import of the results of the test case execution, we can look in the coupling analyze of VectorCAST. For example, we can look at the coverage report that shows which couples exist and also whether or not they were executed with our test cases, which data couples, which control couples. And also in the coupling analyze, we can look at the access order. And the access order can be or is per test case, and that's why it's helpful to have the results per test case. So for example, for the test result, for the test case correct, we see the control couples and in which order they were executed, and also the data couples and the order of execution. So this was the data coupling control coupling analyze. Now one last quick example, a unit test environment, so that you see how simple and fast it is to create a new test environment. We can specify a name. The compiler is already pre-selected because we are inside a VectorCAST project, so we don't need to care about compiler settings or include path settings. This is all preset inside the project. We only need to say what is the file that we want to test. And that's pretty much it. Then when you say build, then we analyze the source code, we build the test harness, we build the stubs, we call the compiler to build the executable. All we need now is the test cases, and they can be defined by the developer or by a test engineer. A simple test case is a call to a function. In this case, the function is called place order. So we have a test where we can specify input values for the parameters of a function. And this can be simple scalar values. Here we see a parameter place order. Order is a struct, and we also analyze the struct, and you can select from a drop down how you want to call the function under test. We can verify return values, and we also have access to the stubs. So when a stub is called, when we dynamically execute this function, then we can tell the stub to verify values or to return specific values. Now, like this, we define input values and expected values, and we can dynamically execute the code. Then we get an execution result like pass or fail. We see that in this case, everything passed. The stub was called with the values as expected, and we return the value as expected. Then we can finally look at code coverage and see which lines of code were executed. And we see green lines for lines that were covered, that were executed. We see red lines for lines that were not executed. And also the color yellow for lines that were partly executed, like this if statement, for example, was only executed with the outcome false and not with the outcome true. Thank you for watching my presentation about embedded software unit tests in the highest level of criticality. If you have any questions, issues, problems with safety-critical software, with software quality, if you need support in testing, embedded testing, software testing, please get in touch with us. Now you can stay tuned and ask questions in the Q&A session. Thanks for watching.